Good afternoon, everybody. I'm going to try to tell you something about 3D printing. You already had a really good introduction about it, and I will show how we at Materialize and at Mobilife, which is a daughter company of Materialize, how we apply it in the medical sector mainly, but also in other sectors. So what is 3D printing? 3D printing is, for example, developing a device that can help saving the life of a small baby. This is a baby boy born in US, and at his birth it had congenital disease at the heart, and therefore it had several defects at the heart. So the doctors were really fearing for the life of this baby. Based on medical images of that baby, a 3D model was created, and that 3D representation of the baby really captured accurately the defects that were present in that heart. A replica of that model was made with 3D printing. It was sent to the US, and there the team of clinicians were able to find a solution in which they could repair all the defects just in one operation. In general, they would need like 3 to 4 operations to do that, but it's really good for such a small baby that it can be done only in one operation. 3D printing is also this. We always get questions about, can 3D printing be applied for weapon manufacturing, because we hear these things in the press. Yes, it can. You can also do that with other production techniques. We at Materialize, we think that there are way more better opportunities to use 3D printing, and we ourselves have a quite strict policy at Materialize to not to refuse any application of our technology for the use of developing or manufacturing weapons. But it is possible, and obviously that raises questions of safety, but I'm sure that the Commission and other policymakers will make good rules to make that safe. We developed 3D printing over the past 24 years. So Materialize was founded in 1990, and since the beginning we have invested massively in research and development, and we also received quite some money from European Union, from Belgium and Flemish government. And what you can see there is the investments of the last years in millions of euros, and you see also the funding that we received through research projects that were funded by EU. And that's massive, and that's important for an innovative company and an innovative sector to advance and to go ahead. So 3D printing, it was already explained to you, but 3D printing is different from classical manufacturing techniques. So it starts not by subtracting material from a solid piece of material, but it actually works the other way around. It starts from a material that has no physical shape. It starts from a powder. It starts from a liquid, it starts from something else, and then energy is supplied so that locally the material solidifies. And if you do that layer by layer, you in the end get a product like this vase. And why would you choose 3D printing to manufacture your products? Because one reason, we think there are several reasons, but one reason is that you can do really great stuff and make beautiful things that you're not able to make in another way, or not using the classical production techniques. So for example, an example from a completely different industry than medical devices is fashion industry. These dresses could not be made with classical ways of producing dresses, but they could be made thanks to 3D printing. Another reason is that you can make things our products at a low cost. I mean, here you see hearing aids, and the hearing aid industry is one of the industries that we are aware of that is currently using 3D printing a lot, and mainly exclusively, to produce these hearing aids. It can be done in an economical fashion, and it has an increased functionality, because now these hearing aids really perfectly fit onto the patient. Another example of one of the advantages of 3D printing is that you can build into your design functional elements of your product. Here you see an example of a bloom, which is a lightning object that's made at Materialize. And functional elements, so the opening and closing of that lightning object, is really incorporated in the design. It's produced as one part. It does not need any assembly whatsoever afterwards. Maybe turning in a lamp, but that's the only thing. And that you cannot do with many other techniques. This is a design example, but in aerospace it's used a lot to make one part which used to be like 10 or 20 parts that had to be assembled to get the same functionality. And why we are here today is for medical devices. So 3D printing can also be used for medical devices. Here you see an example of a craniofacial plate of a patient who had a big tumor at his head, and the surgeon removed that tumor and reconstructed the face of that patient using this metal plate, which was used with metal printing. So how do you do it? This is actually an important slide. Maybe it's even not entirely correct, this slide, because I would have had to put a big cross on top of it, because 3D printing is more than just pushing a button. 3D printing is not just you buy a 3D printing machine, you upload some files that you find on the internet, and you push a button. 3D printing really needs really careful engineering before you have a file that's ready to be uploaded to your printer. And afterwards, you also can have some finishing steps that are needed before you have your final product. So what do you need? You need people that are able to design files or products that can be printed with 3D printing. You obviously need the machines and software that supports these machines. You need the raw materials. You need people that collect the materials once they have been printed, and then people that finish your product so that it's ready to be sold to your customer. I will today focus mainly on medical applications, and there the pre-processing steps, so all steps that are needed before you can actually print an implant or another medical device, are really important. Most of the time you start from medical image data. That can be a CT. And based on that data, you segment all tissues or components that are inside that scan. So here it's an orthopedic application, so you segment the bones that are present in that CT scan. So you get a really three-dimensional view of what the current situation of that patient is. Through interaction between the surgeon and the engineer, you come up with a preoperative plan to make an implant that can be implanted in that patient. So it really fits one patient, it has an exact fit. It's an orthopedic application in the hip, so a hip is obviously a load-bearing application, so your implant has to be strong enough, and it has to be strong enough every time for every patient. So therefore, we, for example, do these simulations, which you see here. This is a simulation that we do before the operation. We simulate how the patient will walk after he had the simulation. So the red things that you see here are the muscles, and you clearly see here the implant. So we try to estimate which forces will be applied to that implant before you actually do the surgery, so that we can assure that for every patient the implant will be strong enough and that the patient can safely walk afterwards for many years. And one of the bigger challenges of the application of 3D printing for medical devices is quality. I believe for us, quality is at the center of everything that we do. And for every customer, you want to make sure that you deliver a real high quality product. So what does this mean for medical devices? Here you see an example of surgical guides. These are guides made by Materialize to support an orthopedic surgery. So say that a patient has a malformation of his arm. These guides say where the surgeon has to drill and where he has to cut. Then the bones are aligned in the correct position, and then they can be fixed again with a standard plate. These are not implants, but obviously these are invasive medical devices. They are used during a surgery, and I think everybody can just feel that the requirements for such a medical device are higher than for another medical device that just makes skin contact, for example. At this moment, in the current MDD and in the new draft of the MDR, these implants are considered as in the general category of custom-made implants. We at Materialize have a little bit of feeling that the current MDR or the draft of the MDR is not taking into account all the aspects that are important for this industry and all associated risks for applying 3D printing to medical devices. but we have provided everybody with a nice bundle where we clearly stated our thoughts, and everybody who's interested can read that white paper and give his comments about it. Another application where we do have an implant, so I think quality requirements are even higher than for an invasive instrument that's only used during surgery. Here, an orthopedic implant hopefully stays many years inside the patient. This is a teenage patient, so here this is a normal hip for people who are not that familiar with anatomy. This is not a normal hip. So the surgeon of this patient came to us. He sent us the medical images and he asked, is there anything that you can do? So I have the model with me also. So actually for us, we do these cases daily. This was also a challenging case. It's a small bone, you don't have much place, and it's severely deformed. But together with the surgeon, we were able to design and produce an implant that nicely fits in there and that I believe helped the patient. Making these things is possible, and current technology can do that. Challenges are sometimes how to commercialize these properly, getting reimbursement of all these implants for special applications. It's not so easy, but it's not easy for us, it's not easy for policymakers. Many actors are involved. But the most important thing is that we can help a patient. And here you see the girl. Before surgery, she was in a wheelchair. She did not attend school. And after surgery, this is almost 1 year after surgery, she was able to walk. She attended school again. Outside, she walked with crutches, but inside she could just walk like that. And I think that's a nice example of what 3D printing can do, what it can do for for medical devices. And with that, I would like to thank you for your attention.